Hi, welcome to my channel. So in this video, I wanted to show you a prototype product that I have made based on the reference from some websites on the internet, and here it is. So this is an oscilloscope which being processed on a microcontroller using Arduino Nano, and the display is OLED, this OLED screen, 0.96 inch. So actually, I've tried this before on a breadboard and it worked at that time. But when I tried to make it on this matrix PCB, I'm not pretty sure on which part that is not quite correct. But there's an input signal and I don't know where that comes from. That's a bit weird. So it took a lot of time to troubleshoot this thing. And for now, yeah, I think I have to make a new one because it's pretty hard to analyze the circuit. Like this is soldered components, and I'm not pretty sure, but on which part is still not quite correct. And so yeah, this is the project that I want to make, and of course this is not the final product. I'm just trying to test the reference that I got, and yet still failed. So I think I need to understand more about how the actual oscilloscope works, like the real oscilloscope one. So from uh, a little bit of research about microcontroller, I found that actually Arduino Nano and Uno has a very low quality of ADC. It's only about 10 kilo sampling per second. That's a bit low. So I tried to look into other microcontrollers which has better ADC, such as this Raspberry Pi Pico. And also this one is quite unique for me because I've never tried this one. So I've got two microcontrollers from STM32, and this one is actually pretty, yeah, this one is actually pretty good for the ADC speed. So from the datasheet, I got that this one, the blue pill, has around 1 mega sampling per second of ADC, and it could support, maybe not support, it could have two channels for an oscilloscope with 1 mega sampling per second, and the price is quite cheap compared to Arduino Nano. So I'm a bit surprised to that. And then this one, the black pill one, STM32F401. So when I search the information about this board, it has a very high quality of ADC with a very cheap price. Yeah, compared to these two. This one is only because I'm from Indonesia and the currency is rupiah, so it's about 60,000 rupiah. Yeah, if I'm not mistaken. And that is about maybe less than $4. So this one is quite cheap. The ADC speed is about 2.4 mega sampling per second, and that is very high. So it's a bit surprising compared to these two. Oh. And yet, when I look into the real oscilloscope, it has a very high ADC, and I don't quite understand how could an actual oscilloscope has that high quality of ADC. Does it even use a microcontroller? That's the thing that I don't understand yet. And in the future, I think I might make an actual oscilloscope that has a very high quality of ADC. Alright, thank you for watching this video and see you on the next one. Bye.